Welcome to my projectbazaar.com. Let me discuss about the project Fingerprint Compression based on Sparse representation. Let me discuss about the abstract of the project. Fingerprint compression using sparse representation has been implemented. Dictionary has been formulated from a set of fingerprint patches. First, construct dictionary based on predefined fingerprint image patches. Every fingerprint image is going to minimize by L0 minimization algorithm. Matching pursuit is a type of sparse representation which involves finding the best matching projection of multidimensional data onto an over complete dictionary D. Compared to general natural images, the fingerprint images have simpler structure and composed of ridges and valleys. In the local regions, they look the same, so the whole image is sliced into square and non-overlapping small patches. For these small patches, there are no problems about transformation and rotation. Size of the dictionary is too large because the small blocks are relatively smaller. Seemingly contradictory effect is achieved in an unconventional optimization framework, making use of L0 gradient minimization, which can globally control how many non-zero gradients are resulted to approximate prominent structures in a structure sparsity management manner. Coefficients can be quantified by Lloyd's algorithm, finding evenly spaced sets of points in subsets of equivalent spaces and partitions of these subsets into well-shaped and uniformly sized convex cells. Finally, all values will be encoded using arithmetic encoding. It is a form of entropy encoding using lossless data compression. It compares favorably with existing more sophisticated algorithms, especially at high compression ratios. In proposed math system, new approach has been proposed, that is sparse representation. In this approach, first initial dictionary has been constructed. In this dictionary formation, KSVD algorithm has been implemented. In KSVD is a dictionary learning algorithm for creating a dictionary for sparse representation via singular value decomposition approach. KSVD is a single generalization of K-means clustering method, and it works by iteratively alternating between sparse coding the input data based on the current dictionary and updating items in the dictionary to better fit the data. Next, every image will be compressed by matching pursuit algorithm method. L0 minimization process has been implemented. Matching pursuit is a type of sparse approximation which involves finding the best matching projection of multidimensional data onto an over complete dictionary D. Next, total number of each patch, mean value of each patch, indexes of each patch. The coefficients are to be encoded by arithmetic encoders. Arithmetic coding is a form of entropy encoding used in lossless data compression. Normally, a string of characters such as words hello there is represented using a fixed number of bits per bits, as in ASCII code. Finally, all compressed values has been combined and updated into dictionary. Let me discuss about the flow diagram for our process. First, capture the input image from the source file by using a getFile and imread function. User can be able to change the size of the image by providing the pixel height and width with the help of imresist function. Can remove the noise in the image using filtering function. Here, fingerprint images are taken as an input images. In the pre-processing, noise removal has been performed. Based on the noise removal, the noises will be removed from the fingerprint images. Next, in the patch conversion, first capture the image from database. Convert the image into patches. The size of the patch depending on the mentioned size. All patches comprised of an image. Each patch is saved and processed for further. Next, in the dictionary formation. In dictionary formation, each patch is placed to construct dictionary, which can be performed by KSVD algorithm. KSVD is a dictionary learning algorithm for creating a dictionary for sparse representation via a singular value decomposition approach. KSVD is a generalization of the K-means clustering method, and it works by iteratively alternating between sparse coding and input data based on current dictionary and updating the items in the dictionary to better fit the data. KSVD can found widely in use in the applications such as the image processing, audio processing, biology, and document analysis. The goal of dictionary learning is to learn an over-complete dictionary matrix that contains single atoms. A single vector can be represented sparsely as a linear combination of these atoms. To represent the representation vector should satisfy the exact condition or the approximate condition made precise by requiring that for some small value sigma and small L0 norm. If it is a full rank matrix, an infinite number of solutions are available for the representation problem. Hence, constraints should be set on the solution. Also, to ensure sparsity, the solution with the fewest number of non-zero coefficient is preferred. Thus, the sparsity representation is the solution of either or where the norm counts the non-zero entries of a vector. Please See the matrix normalization formation. Next, in the compression stage, here in compression method, matching pursuit algorithm has been implemented for every minimized patches. Minimization has been obtained by subtract the mean values of each patch from the patches. Matching pursuit is a type of sparse approximation which involves finding the best matching projection of multidimensional data onto an over complete dictionary D. Given a first dictionary, matching pursuit will first find the one atom that has the biggest inner product with the signal, then subtract the contribution due to that atom and repeat the process until the signal is satisfactorily decompressed. And for comparison, consider the Fourier series representation of signal. This can be described in the term given above, where the dictionary is built from the sinusoidal basis function. The main disadvantage of Fourier analysis in signal processing is that it extracts only global features signals, does not adapt to analyzed signals. Next, the coefficients of patches will be quantized by Loydal's algorithm, also known as Warnide iteration of or relation. It's an algorithm named after Stott Lloyd for finding the evenly spaced sets of points in subsets of equivalent spaces and partitions of these subsets into well-shaped and uniformly sized convex cells. Likely the closely related K-means clustering algorithm, it repeatedly finds the centroid of each set in the partition and then repartition the input according to which the centroid is closest. However, the Lyell's algorithm differs from K-means clustering in that the input in continuous geometric region rather than a discrete set of points. Next, the atom number of each patch, index values and the mean value of each patch has been estimated. Finally, all values will be coded using arithmetic coding. Is a form of entropy coding used in lossless data compression. Normally, a string of characters such as the words hello there represented using the fixed number of bits per character. Finally, the updation of the dictionary will be performed by kernel singular value decomposition algorithm. Finally, all coded values will be updated based on compressed stream using SVD algorithm. Let me discuss about the running procedure for our process. Select the fingermain.m file in the current folder, right-click that file and run for executing this process. This is the main window of the fingerprint compression. By pressing the input image button, we can browse the input image from the dataset folder. Select any one images from the dataset folder. Here I display the input image in the Access 1 plot. By pressing the pre-processing button, we can browse process our fingerprint, that is removal of noise from the fingerprint. Here I display the pre-processed result. By pressing the convert patches, we have convert our fingerprint into number of patches. Here I display the converted the 4 patches, and by pressing the minimization we perform the mean subtraction result. Here I display the mean subtraction result for every patches. By pressing the dictionary formation we perform the construction of dictionary. Here the dictionary has been constructed. By pressing the compressed stream we perform the compressed stream, that is mean value of each patch, atom number of each patch and index of each patch has been coded using the arithmetic encoding algorithm. This process will take some time for executing. Finally, we got the compressed stream for our first fingerprint images. This compressed stream represents for every patches, and this is the compressed stream for image 1. This is the compressed stream for image 2, and this is the dictionary representation for database first 2 images. This process will be repeated for entire database images. Now, by pressing the decompression process button, we can perform the decompression operation, that is reversal operation of our compressed process. Here we obtain the decompressed result for every fingerprint patches, and also the reconstructed image will be obtained the combined combination of patches and we obtain the original image. Finally, we analyze the performance of the processes, that is we need to evaluate the compression ratio for our processes. Here I display the compression ratio which will be 0.08, that is 80% will be compressed. Here we obtain the graph between existing and proposed system. This is the X label represents the number of execution and Y label represents the compression ratio. Finally, the compile interoperabilities among adjacent patches are enforced both locally and globally. Despite the simplicity of our proposed algorithm, they compare favorably existing more sophisticated algorithms. Thank you.